about 125,000 feet or so when the solid rocket boosters come off. And once they come off, so you're about 25 miles high. And then we actually start pitching over a little bit, and you can see us flattening out our trajectory here. We'll actually pretty much parallel the surface of the Earth as we accelerate going out. And once we get out there, the computers shut the engines down at 26,000 feet per second, give or take. And we jettison this tank, the only part of this whole system that was not reused. And it would re-enter the atmosphere and burn up over the Pacific Ocean. You can see this one, it had kind of a rough life. There it was nice and pristine, one color when it was on the pad. Here you can see the charring from the heating from the engines, and over here from the booster motors. On our mission to bring a couple of pieces of the space station up, we had to get above or catch up to the space station and dock. It took us 2 days to do that. And I flew the rendezvous. We're over the Sahara Desert right here. Flew us around to a point above it. Koichi used the robotic arm to put the pieces in place, and then on 4 consecutive days, my other crewmates went out and did spacewalks to hook up all of the pieces that we had added so that they would work. When the mission's over, it's time to come home. It's kind of interesting. You only have to slow down about 400 feet per second. That's enough to bring you back to start touching the top of the atmosphere, and then that drag slows you down. And that's how we come back in. It's a real show, though. This picture was taken at night, and looking out the window there, you can see it looks pretty bright. That's because when you're hitting the upper atmosphere and you're still going as fast as we are, you start knocking electrons off of the atoms, so you create all this charged gas around you. And the scientists call it plasma. And the fighter pilot in me says, I know what that is. It's not plasma, it's fire. We're surrounded by fire. So 60 minutes after you do that deorbit burn and slow down, you are going to land. Once you do the burn, you're committed. If you want to land in California, you just do the deorbit burn about 6 minutes earlier than if you want to land in Florida. That's about how long it takes to cross the country. So I've got a short video here. I guess I can probably stay up here and talk that we took on about our last mission. Here's the patch that we designed, kind of to try to capture what you're doing on the flight in the patch design. It took us a number of tries to get off the ground, and they say that this is actually the one where we went, the walkout that we went. It took us about, over the course of 9 days, I think we tried about 5 times. And this is what it's like getting into my seat. So if you think about it, the space shuttle's on its tail, and my seat's way up there. And so here's Cam climbing in, and it's a good thing that we have people that are helping us, or we'd still be out there. and this was 11 years ago. So here's main engine start. These sparklers start firing first, and that's because if there's any residual hydrogen around, that's a flammable problem, and we want to burn that off. And the boosters light. You'll see here inside. Here's what it looks like as the engines start. You get this high frequency, low amplitude vibration, and then when the boosters light, right there, it all changes. And we often say that when the boosters light, you're going somewhere. You don't know where, but you are going. We went past this, we had a little cloud deck that went by us like nothing. 2 minutes in, the boosters are coming off. We launched about 45 minutes after sunset. So here's what it looks like. Those are the motors that fire to push the boosters away from us. And things smoothed out inside. And so I mentioned earlier that those come off at about 25 miles of altitude. Well, right here, I reached over and I congratulated my rookie astronaut, Pam, because we had just passed 50 miles of altitude. She had just become the planet's newest astronaut. So, yes, once we get up on orbit, one of the first things we do is open the payload bay doors, and that's important because the lining of the payload bay doors is actually a radiator, and that radiator we use to get rid of the heat that we generated during the ascent and during the mission. So those things have to work. If they don't work, if you can't get the doors open or the radiators don't work, then you're coming home pretty much right away. Fortunately, 135 missions of the Space Shuttle program, we never had to do that. We trained for it, however. That's one of the things you train for. So here we are, finally catching up to the station. The rendezvous was not without incident. The day before we were to do the rendezvous, the radar failed on the shuttle, so we had to do the only no radar rendezvous with the station. So there's a target right here as we're closing in on it. There's a target there, and I'm looking across the cockpit at some monitors that are right there, and I have a camera view that's outside, and my docking mechanism looking straight up, so it's looking straight at that target. And this is my job right here, keep that centered. So as the two vehicles are coming together, my job was like playing a video game, but it was just to bring them together right there. We had about a couple seconds to celebrate, high-five each other, and then it was our time to get right back to work. So what we do after docking there is we mechanically pull the pieces together and seal them. That way, here you see it's all tied together now. And then that way we can let air into what's now a transit way for us to be able to get from the space shuttle up to the space station. So here's the hatch in the space shuttle middeck. We're opening it. And we're coming up now to the hatch that's on the space station. And you'll see Mike move the hatch. It probably weighs 400 pounds down here on the ground, but you'll see him, he'll just move it with 2 fingers. As it slides out of the way because everything being weightless up there. It's really a cool experience. So Mike starts in, and then he backs out and he says, "No, Brian, you're the commander. Why don't you go in?" And I thought, what a nice guy. Let his commander be the first one in there, in the station, because there wasn't anybody in the station at the time. And it was only later that I think I realized he was using me as the canary in the coal mine. You can see the whole floating thing's pretty easy to do. So the scientists here at the Johnson Space Center wanted to understand what the atmosphere inside the station was going to be like. So that's not a holy hand grenade of antioxidants. That's an air sample bottle that we had to. So the first thing we did, because the station had been buttoned up for quite a period of time, they wanted to understand what the atmosphere the people would be breathing when they went up there full time. So that was that sample. Little cartoon of Koichi. What he had to do. This is obviously much faster. That truss that you see there, that big box, that thing doesn't look so big, but it's about a 15-foot cube, weighed about 20,000 pounds, and it was just full of equipment. Here I am with that IMAX 3D camera. We were shooting scenes for a movie. While we were training, they said, "We know you're going to be busy, but would you mind making a movie while you're up there?" So they actually taught us to be like movie directors. And Pam's in a bag here, changing out the film, trying to protect it from any ambient light. Probably the coolest thing that we did on the flight was we got to fly a self-rescue jetpack. So in the past, in the program, before this time, if someone was doing a spacewalk and they became detached and started floating away, then as the commander of the shuttle, I could fly the space shuttle over and rescue them if I liked them. And we're not going to have that option on the station. So here you see this is Mike Lopez Alegria. And he's got a little control box right here. He'll put some inputs in. You'll see it change his trajectory, but you can see how stable he is. And so now anytime any spacewalks are done on the space station, they wear these things that we did on our test flights here. So in our mission, we had those 4 consecutive days of spacewalks, and we had one more day where we were docked to the station, and we were going to transfer supplies there. And so what you see in here are these bags. There's no up or down, as you can tell by whoever's in the camera here. So there's no ceiling or floor, so you just take things and stow them where you could stow them. The lockers were already all full, so we had to just stick them in the front there. But that was things like food and clothing, experiments that the people that were going to be on the station were going to need. So